Unit 15 is all about the Earth and beyond, and we have split this subject up into 4 sections. Let's first look at the movement of our own planet, Earth. As you're watching this program, you don't have a sensation of movement. It's not obvious that our planet Earth is moving through space at a speed of thousands of meters per second. So it's not surprising that early astronomers made the mistake of thinking that the Sun moves around the Earth.
How do we go from day to night? It's nighttime in part of the world, but it's daytime in other parts. Britain faces the sun. It's daytime. But the other side of the world is in darkness. In Australia, it's the middle of the night. But the Earth rotates. As it rotates, parts of the Earth that were facing the sun turn away from it. The Earth rotates one complete turn every 24 hours, so day is followed by night, is followed by day.
So that accounts for daily changes from darkness to light. But how about the different seasons? How does the movement of the Earth cause these seasonal changes? This is the kind of question that appears in the test, so watch this next clip carefully.
In winter, the North Pole is tilted away from the sun. But as the Earth moves around the sun, you can see the amount of daylight increasing in the north. The days get longer in the north in springtime. By June, the Earth has moved round the sun, so the North Pole is now tilted towards the sun. The Earth takes a whole year to orbit the sun, and it's this which gives us seasons.
So the Earth orbits the sun once every 365¼ days, which makes a year. And it's this combination of the orbit of the Earth and the tilt on its axis that gives us the different seasons. Let's have another look. In winter, the north end of the Earth's axis is tilted away from the sun. This means in the northern hemisphere the weather is colder and nighttime is longer than daytime. This is directly opposite to what happens in summer, when the Earth's axis is tilted towards the sun, when the weather is warmer and the daylight hours are longer. The Earth rotates on its axis once each day, and at any time half of the Earth is in daylight and the other half is in darkness. The Earth orbits the sun once each year. This is due to the gravitational pull of the much larger sun. During the night, the stars appear to move across the sky. And during the day, the sun also appears to move across the sky. But of course, we now know that both the sun and the stars' apparent daily movement is because of the Earth's constant rotation about its axis. Let's look more closely. In the northern hemisphere, on a summer's day, the sun appears to move in a curved path across the sky. It rises in the east and sets below the horizon in the west. But during the winter, when we're tilted away from the sun, this means the sun will follow a different arc across the sky. So in the northern hemisphere in winter, the sun now follows a much shallower arc. Daytime is shorter than nighttime, giving us colder days than the long daylight hours in the summer. And during nighttime hours, stars also appear to move across the sky in curved paths, apart from the pole star. As it is directly above the North Pole, it doesn't appear to move. We're now going to look at the solar system, which our planet, Earth, is part of. The solar system is made up of the Sun, which sits in the middle, and the 9 major planets which surround it. These planets move around the sun in slightly squashed circles called their orbits. And all these planets, including Earth, stay in their orbits and don't go cartwheeling off into space because of the gravitational pull of the sun. Like other stars, the sun in our solar system is a light source. Remember, we can only see the planets because light from the sun is reflected off them to us. It's important for your test that you know the order of the planets well, and these next clips will help you memorize them.
What we call our solar system is a family of 9 planets moving around the sun. Their predictable paths are called orbits. Closest to the sun is the planet Mercury. Next comes Venus, and then our own planet, Earth. Still moving away from the sun, our other neighbour is Mars, the red planet.
So far, we've got Mercury nearest the sun, then Venus, then our own planet Earth, and then the red planet Mars. So that takes us up to 4, and they're called the inner planets. So what about the outer planets?
What are these outer planets? The first is Jupiter, orbiting 780 million kilometres away from the sun. Then comes Saturn, double that distance away. Next is Uranus, then Neptune, and finally Pluto with its strange orbit. All of these outer planets were thought to be very similar, but they're so far away, they're very difficult to see with ground-based telescopes.
So the other planets are called Jupiter, Saturn, Uranus, Neptune, and then Pluto. Here's a way of remembering them.
To remember the order of the planets, I had a rhyme, and it was many various Egyptian men jump slowly under new planets, and it was the first letter of each word that reminded me the first letter of each planet.
The way I remember the 9 planets is many very energetic Martians jumped straight under 9 planets, which is all the planets together.
So you should know that the sun is at the center of the solar system. The sun is a star. It gives out light, it is a light source, and we say that it is luminous. The planets do not give out light, and we can only see them because they reflect light. And all the planets stay in their orbits and don't fly off into space because of the gravitational pull of the sun. So, here's a question for you. How many planets take more time to orbit the sun than the Earth, and why? Well, we know there are 9 planets. Can you remember where Earth comes in the sequence? Why not stop the tape and have a go? Or you can move straight on for the answer. So, the answer to the question, which planets take more time to orbit the sun than the Earth, and why? Well, moving outwards from the sun, the Earth is number 3, so that leaves 6 planets. And because they are further away from the sun and have larger distances to travel, they take more time to complete their orbits. If you weren't sure of the answer, why not run through the top tips again, or think up your own rhyme for remembering the order of all 9 planets. First, let's sort out what a satellite is. A satellite is a body that orbits, in other words moves around, a much larger body. And for your test, you need to know the 2 different types of satellite: natural satellites and artificial ones. Let's look at natural satellites first. The Earth and the other planets are natural satellites of the Sun, while the Moon is a natural satellite of the Earth. The other types of satellite you need to know about are artificial satellites. These move around the Earth and have been put into orbit by us. There are lots of different types of artificial satellites. Make a note of the different ones as we run through these next clips. These machines are launched into space for many different uses. Some satellites collect information about the weather and will orbit the Earth several times a day to monitor changes in the conditions. Others are used for navigation, telecommunications, and for collecting a wide range of information about the Earth's surface, including spying. So satellites are small objects which orbit around a much larger object, and there are two different types of satellite. Natural, for example the Moon, and artificial, for example machines often used for communication purposes. That brings us to the end of this unit on the Earth and beyond. Before you move on, make sure you understand how the Earth moves around the Sun and where it appears in the order of planets in our solar system. If you weren't sure of any of the key points, you can always rewind and go through them again. The book and website have lots of test questions on these topics, and this is a good place to take a break.